I have here Adoric brand caliper plastic with large screen, and this one uses lithium battery, one spare, one's inside with the protective tab. And this thing I did measure before, and they take 27 microamps when they are in the off position and 30 microamps when they are in the on position. So the difference is about 3 microamps or 10%. So it basically doesn't matter whether this thing is on or off. And because of that, I'm going to install a switch, one of the little switches. And this thing is a little bit too big to fit in this space, which is limited in this caliper. So I'm going to place it on the top. I'm going to open it up, disassemble that part, and put the switch right here on the top. And I'll show you step by step how to do it if you have this kind of caliper. That's Adoric plastic. Now this one comes with no case, no protective case, which is a shame, because even the cheap $10 range calipers have some kind of a simple protective case. This one has nothing, just a blister pack. Now this thing is taken apart, and I can tell that the positive will be the only one terminal that I can cut and make a switch. Now what I'm going to do is, in order to see the trace from the positive, I'm going to place it on a flashlight. When you shine flashlight through the board, you can see the traces, and I'm interested in the trace running from this terminal. The little trace has been cut right here, and the trace from this terminal, and you can see it when it runs, it's the first one parallel to the mesh, which is the grounding, which is the negative part of the battery. But this has been cut, and the switch will be between this soldering point right here and the soldering point right here on the voltage regulator. The switch has been mounted just like I did it before. Now I used to put them under the display. Now it's over the display, and inside you can see this is what it looks like. And as I said, you just heat up gently the side of your soldering iron the terminals, the metal terminals, and then they will melt into the plastic, and then you can bend them inside, and this will be the connection for the switch. The magnet wire that I'm using comes from a transformer, and this is a little like 3 or 4 watts transformer, and I'm using the wire from the primary winding, from the 120 volts winding, which is perfect for the purpose. The 2 wires are soldered. One goes to the chip, the other one goes to the battery terminal, the positive. And now I'm going to put the board together, put the screws in, and run it to the switch. The switch has been soldered, and now it's time to put the screws in and test it out. Now if I try to test this part by inserting the battery, as I did, and turning it on, the display will go a little crazy. It will just show everything. However, as soon as I place it in the corresponding part right here, it will quiet down, and then I can actually use it. So it will work when it's connected, when it's placed in the body of the caliper. Now the caliper is done. It works great. You can turn it off like this. This one also had the option that when you turn off the switch like this and just move the caliper, it will turn on. The problem with it is that it's a constant draw of 27 microamps compared to 30 when it's on. But if you turn it off just like this, the draw from the battery is constant 27 microamps. If you turn it off, there is nothing. So this is really, really practical to save your battery, and it doesn't take a lot of space. In this case, I couldn't fit it in the bottom. There was not enough room, but I could put it right here on the top. And I also peeled this sticker using hair dryer on hot and put it right back so it looks original, plus the switch. Well, thank you for watching. Give it a thumbs up if you liked it.